So we looked yesterday at Lewis structures of ions, and today we're going to look at Lewis structures of ionic compounds. Okay, so rather than looking at ions in isolation, we're going to look at the formation of compounds. Now, just a little reminder here, an ionic bond is the attraction of a cation for an anion. So, if I have a cation and I have an anion, positive and negative attract. There is an attractive force between those, and that is the ionic bond. Now, in actual fact, there's no real space to speak of between the ions. They would be one right beside the other. Yes, and we would have, it's like when you have a magnetic force, I've got this magnet. It's not like there is a force when I hold it near the board, like I can feel it trying to pull to the board, and if I let go, it's just about 5 millimeters away. It clicks into place, okay? But once they're touching each other, that force is still there. It's just hard to draw that force. So that's why I sort of showed them as being a little bit apart so you could see that attractive force. But this is our ionic bond. And it's just the attraction between positive and negative, because positive and negative attract. It says, remember the smaller nonmetals are more electronegative. You don't know that word yet, so you're not going to remember that very well. This is more like if you had been in, because I use the same sheets for my enriched class and this class, and their atom unit is significantly different than yours. So anyway, doesn't matter. You can just ignore this part here. Blah, 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 blah. Okay. Now, when we are naming ionic compounds, we always name the metal first. Okay, so the metal comes first. Sodium is the metal. Followed by the nonmetal, so the nonmetal comes second. And when we have an ionic compound, this is the sodium ion. And you'll notice that its ending is not "ide." Yes, because cations do not change to "ide." And then we have the fluoride ion. And that ending does change to "ide." So yes, "ide." Because it is the negative ion, and the ending of negative ions change to "ide." The ending of positive ions do not change to "ide." You don't say sodiide chloride, and you also don't say sodium chlorine, right? So that we have our Na plus and we have our F minus. So what that would look like is we would have an Na plus ion and we would have an F minus ion, and they would be held together by what kind of a bond? What kind of a bond do we have between sodium ion and fluoride ion? That would be an ionic bond. Shockingly, between ions, we have an ionic bond. Okay. What do we call a single unit of an ionic compound? That is a formula unit. So what we have drawn here, this is a formula unit. And it is the lowest whole number ratio of elements in a compound. So for example, if we have calcium nitride, and this is going to be a little preview of the next unit, so you don't need to be able to do this for this unit, but you would know that calcium is in group 2. How many valence electrons does calcium have? 2. So when it becomes an ion, what does it do? It loses 2 electrons, so its charge is plus 2. So calcium is 2 plus. Nitrogen is in group 15. So therefore, how many valence electrons? 5 valence electrons. So nitrogen, when it becomes an ion, will it lose or will it gain? It will gain how many electrons? 3 electrons. And so the charge of nitride ion then is N 3 minus. And I guess I'll write down calcium. We had group 2, therefore 2 valence electrons, and so it would lose 2 electrons. Do you remember how to make a formula with an ion that has a 2 plus charge and an ion that has a 3 minus charge? Tell your partner if you see if you can remember with each other. If you can't, it's okay. I'll help you out in a minute. Yeah, you can just do your thing. It's okay. You could talk to Cassie over there all by her lonesome. Common multiple. Lowest common multiple. What is the lowest common multiple of 2 and 3? 6. So what I could do is I could have 3 calciums, which would give me a total of positive 6. And I could have 2 nitrogens, which would give me a total of negative 6. Because the goal of having a compound is to have the overall net charge equal to 0. And what that means is that in order to have the net charge equal to 0, because all compounds have a net charge of 0, all compounds, we would need to have 1, 2, 3 calciums. So we would write Ca, and then in order to show that there are 3 of them, we would write a little 3 down here. Whoops. Don't want that. Delete. There we go. And we would need 2 nitrides. So we would write N2. Okay, and that is a formula unit of calcium nitride. So the formula unit would look something like this. Ca2 plus, N3 minus, Ca2 plus, N3 minus, Ca2 plus, and that would be a formula unit. Heaven help us if we wanted to draw the crystal lattice for this thing. Okay, it's not tidy. It's not like sodium chloride, sodium chloride, sodium chloride. It's a more complex structure. You will never have to draw a crystal lattice for a non-one-to-one compound. Okay, it just gets too icky too fast. Okay. So that is like a little preview of all the concepts that go here, but now we are going to use Lewis structures and we are going to use arrows. Many people forget the arrows, so don't forget the arrows. And we're going to illustrate the transfer of electrons from the metal to the non-metal. This is the transfer of electrons from the metal to the non-metal. And then once we've done that, then we will write the Lewis structure of the compound. Finally, we're going to draw a formula unit. We're going to write the formula unit, which is basically just the chemical formula. And then we're going to name the compound. So the examples are written out here, but I'm going to do them off to the side. So if you want to follow along with me, you can either just look at what's there or you can cover it up and write along with me. So we're going to do the first example, which is sodium and chlorine. So A, we're going to do the Lewis structures of the atoms. Sodium is what group? Have a periodic table out. Sodium is group 1. How many valence electrons? 1 valence electron. And don't forget, I like to write VE for valence electrons because it just makes it shorter, okay? So when we write the Lewis structure for sodium, we draw Na, and I'm going to put the electron right there. It's got 1 electron. So I'm not going to label that because we're going to need arrows later. Chlorine, what group is chlorine? (17). It is a halogen, and therefore how many valence electrons? 7 valence electrons. So when we draw chlorine, and I'm going to draw it in a different color here, and also I'm going to make these little X's, those are also going to be electrons, okay, just so you can see the difference between them, okay? So we have these guys, which are electrons, and the little X's, which are electrons. So for chlorine, we have 7, 1, 2, 3, 4, 5, sorry, 5, 6, 7 electrons. And if we look and we say chlorine has a gap here, swallowed some of my spit the wrong way, really gross, okay. And sodium has 1 electron. What would sodium like to do to become stable? Yeah, become stable. Na should lose an electron. And what should chlorine do? Chlorine should gain an electron. So, oh, wouldn't that be nice if we took this little electron here and we moved it right into that spot there. So this is what I mean when I say use the arrow to show the transfer of the electron. So many people forget this step, and it irritates me. So don't forget it. Show the arrow. Show the electron going whee, over here. Okay. Now we're going to redraw it. And we're going to redraw the Lewis structures of the ions. Okay, so sodium has now lost its electrons, so the only thing that's left is Na. Right? This electron that's right up there, it's now gone, right? It's gone. Now what do we do when we turn it into an ion? We put brackets around it and we put its charge. So it's Na plus. And then chloride, it has its original 1, 2, 3, 4, 5, 6, 7 electrons, but it also has the 8th that it got from sodium. And because it is now an ion, we will put brackets and we will put the charge. So that is the Lewis structure of the ion. So we drew the atoms and we showed the arrow showing the transfer of electrons. And then we redraw it showing the electron having been transferred, use brackets, charges. And then finally, we're going to write the formula of the compound. And in this structure, how many NAs do we have? We have 1 Na and we have 1 Cl minus. So when we write the formula, we write NaCl. If there's no number, that means 1. Okay, same thing here. If there's no number, that means there's 1. Do I write the charges in the formula of the compound? Do you see any charges? No. Okay, so just NaCl. I'm going to rewrite it because I've written stuff all over that. It would just be NaCl. There we go. And then finally, we want to name the compound. And we name the first one sodium. Do not change the ending of the name. That's our metal. And then second, we are going to have chlorine becomes chloride. So the nonmetal comes second. Yes-ide. Okay, so that's a super easy example. We're going to do a couple more without all of the extra writing. We'll just do the bare bones of it. So let's take a look at magnesium oxide. Magnesium and oxygen. Magnesium is in group what? Yes, yes. Magnesium is in group 2. Therefore, we have 2 valence electrons. Oxygen is in group 16. Therefore, we have 6 valence electrons. So now we're going to do A. We are going to draw the atoms and arrows. So magnesium has 2 valence electrons, 1, 2. Oxygen has 6 valence electrons, 1, 2, 3, 4, 5, 6. And it has 2 little gaps. You don't have to draw the gaps, but if you want to, you can, because sometimes it's helpful to see them. So drawing the gaps is optional. What isn't optional, though, is drawing the arrows. Okay, drawing the arrows is not optional. So we're going to take this electron from magnesium and put it into a slot, into a gap. And we're going to take this electron and put it into a gap. And then we're going to redraw, we're going to draw the ions. So we have Mg. It has lost 2 electrons, so its charge is 2+. We have oxygen, which has its original 1, 2, 3, 4, 5, 6 electrons. Thank you. And then we have the 2 electrons that it got from the magnesium. Okay, and because it gained 2 electrons, its charge is 2-. And you'll notice we have a 2+ and a 2-, so the overall charge is 0. Okay. Okay, and now we are going to write a formula for this. So that's going to be, I just have 1 Mg and I have 1 O. So that's really easy. And then I name it. Mg is magnesium. And what do I have to do with the O? I have to name it oxide. Why not oxygen? Other than the fact that it just sounds weird. Most anions, in fact, almost all anions only have 2 syllables. Oxide, not oxide. Okay, oxide. So if I was to take Catherine here, Catherine, 3 syllables, if you spread it out, we would not call her Catheride, we would call her cathide, which is almost like a cation, which is kind of cool. Thank you for being a demonstration there. Okay. All right. Last one. This is magnesium and nitride. This is a more complex example. Magnesium and nitrogen. Magnesium is group 2. Therefore, we have 2 valence electrons. Nitrogen is group. What group is nitrogen? Yes, it is group 15. Therefore, we have 5 valence electrons. And so now we can take our atoms. We're going to have our atoms and arrows. Here's magnesium with 2 electrons. Here is our nitrogen with 1, 2, 3, 4, 5 electrons. So we've done our atoms. Now we need to do our arrows. Oh, and I guess I could put in my little gaps here just so I can see them clearly. Okay, so this is super nice. Here goes magnesium's electron, it goes there. That one goes there. And then I say, oh no, what happened? I still have a gap in nitrogen. What shall I do? I'm going to add another magnesium. So anytime you have gaps that need filling and you don't have enough electrons, or if you need an electron to go someplace and you don't have a gap to put it in, you can simply add atoms to make it work. Okay? Until all the gaps are filled and all the electrons have been moved. All methyl electrons have moved. So let's put in another magnesium, shall we? Here we go, Mg. There's an electron, and I can take this electron and move it up here. Hooray! I must be done yet. Am I done? No, I'm not. Because this guy is happy, right? He's got all his electrons gone. This one over here is now happy because it's filled up all its slots. But this magnesium is still sad because it's got that one electron that still needs to go somewhere. So remember, if you need to, what can you do? You can add atoms. So we're going to add another nitrogen. 1, 2, 3, 4, 5 electrons. And here we go. So we have, oh, I should put in my little gaps. Gap, gap, gap. Here comes this electron. In it goes. Hooray! Now that little magnesium is happy. What about nitrogen? Not happy. Oh, so sad. Because it's still got 2 little gaps in it that are not filled. So we need to do what? Add an atom. So we're going to add something to fill those gaps. So we will add another magnesium, Mg. And we will draw the arrows. Here goes this one right there. And then this one goes there. And now this nitrogen is happy. And magnesium is happy. Oh, everybody's happy. So our formula, oh, no, not our formula yet. Now we need to do our ions. And there's two choices for how you can do this. You can draw it like this, Mg, 2 plus, Mg, 2 plus, Mg, 2 plus, and 1, 2, 3, 4, 5, and 1, 2, 3, 4, whoops, 3, 4, 5. Fill in those extra electrons there, electrons there. And then this is 3 minus, and this is 3 minus, and that would be fine. I find that a lot of work though, like it's tiring. Okay, so you don't have to draw it that way. You could say I have 3 Mg 2 plus, and I have 2 N with all its electrons. 3 minus. Okay, so either that or that. Whichever you like, whichever is easiest for you. And then we will write our formula, Mg N. Yeah, you should be doing that with your eyebrows. You should be looking at me like, what? What have I done wrong with my formula here? My subscripts, because I should have 3, 1, 2, 3 magnesiums. So I'm going to put my little 3 down beside magnesium. And I should have 2 nitrogen, so I'm going to put my little 2 beside nitrogen. And then the name becomes, remember, we do not change the name of the metal, but we do change the name of the nonmetal nitride. Okay. And there we go. So we now know how to do Lewis structures of ionic compounds. So on page 89 and 90, you could do number 1, 2, 3. Would you be able to do pages 89 and 90? Just 89 and 90, numbers 1 through 7? And if you're like, wow, that's even too much for me tonight because I have to pack for my band trip and yada, 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 and whatever, you can be like, I will just do 1, 3, 5, 7. Yes, because that would give you a taste of what there is. And don't forget, if you have not done 81 through 86, you will also want to do those. And I think we're done. Yay. Yes. You can do it either way. It doesn't matter. You can put a plus. So apparently in the actual notes, I have a plus in between them. That's optional whether you put it there or not. Okay. You can just put them beside each other. Because they share and they do, yeah. You get single bonds, double bonds, triple bonds. Big bonds.